In this video, we demonstrate how to choose optimal warehouse location or locations. So the background of this is, let's say there's an e-commerce company and Amazon, and we all know that Amazon is in Seattle. Seattle is kind of at the corner of the United States. So as an online retailer, if Amazon were to ship products to consumers, it's far more convenient not to ship directly from Seattle, but pick a warehouse in a different location. So in this video, we're going to use Excel to find the optimal location that can minimize the shipping cost to the continental United States. And we examine two cases. First, with only one warehouse, and second, what if we have two warehouses? One specific calculation that people are not very familiar with is the distance calculation on a globe. Because the Earth is not flat, so the distance between pairs of cities is not a straight coordinate system that we calculate x squared plus y squared and then take a square root. Instead, we need to take into account of the globe, which is why the approximate distance on a globe is this equation. And 69 is approximately 1 degree of difference in latitude or longitude, translates into approximately 69 miles. So this is the distance formula that we're going to use. So first, let's take a look at the data we have. So we have all the major cities listed here in the United States, and they're categorized are cities, and separately we're going to have the warehouse. It's a different category, and for each city we have the city's latitude and longitude. And then based on our expectation, we know how much we're going to be shipping to each one of these cities. A larger city like New York may experience a larger volume of shipment, and Boston may be less. So that's the data we have. So first, let's calculate the distance from the warehouse to different cities. So distance is equal to, using the formula that we have here, 69 times the square root, parenthesis, and parenthesis. So it will be the latitude here in C2 minus the latitude of the warehouse, which is in C23. We want to lock this, so use the F4 key to lock this, and then close the parenthesis, and then take a square. So that's the difference in latitude. And then now plus the difference in longitude square. So parenthesis, this longitude minus the warehouse longitude, lock down, F4, and then close the parenthesis, and then also take a square. Now close the square root parenthesis and enter. So that's the distance between New York and this unknown warehouse. Right now we have nothing, so it's treated as 0, 0. So let's not worry about it for now, because that's the latitude and longitude we want to find out using solver. So now we can copy this formula all the way down to all these different cities. Next, we want to calculate shipments timed distance, because this reflects the total cost. And that's equal to the shipments multiplied by the distance. And similarly, copy this down. Don't need that. And now we want to calculate the total is equal to the sum of shipment multiplied into distance, parenthesis, and enter. And then we want to calculate the mean distance. The mean distance is simply this number total we have here divided by the sum of all the shipments. This gives us the mean distance, and enter. So it's 7,123. And next, we're going to use solver to minimize this total of shipment by distance. So go to data, solver, and the objective is this. And here we want to minimize it, so it's not max, it's min. And by changing variable cells of these two, latitude and longitude. So we want to find out the latitude and longitude of the warehouse in order to minimize the total shipping cost. And we want to set a few constraints. First, it's helpful to know that in the US, the latitude is within 0 to 50. The longitude is within the range of negative 150 to 0. So that's just the way latitude and longitude are defined. So we're going to add the constraint of latitude to be less than 50. Okay, and then add the constraint of the longitude to be larger than negative 150. Click OK. And then add the longitude should be smaller than 0. And then let's just get the latitude as well, larger than or equal to 0. Alright, so now we have set constraints on the warehouse location. It has to be in the United States. So now we're going to find the warehouse location. And in this case, we only need GRG nonlinear. The reason being that when you think about all the calculations we have done squares, we have done square roots, but there's nothing about if or anything else. So there are no kinks in this calculation. So we can use GRG nonlinear, go to options, and this is a relatively complicated problem too. For GRG nonlinear, we're going to use multi-start, as we have explained in the previous lecture. And click OK, and then solve. Pretty quickly, so we have the solution, and click OK. Now we keep the solution, and we find out that the optimal solution for a single warehouse is here, and the mean distance is about 1,126 miles from the warehouse to these different cities. So you may be curious, where is this location? Let's take a look. So we can copy these two, Control C, and let's take a look on Google Maps. So in Google Maps, paste down these two, just Control V, and putting enter. And Google is pretty good at this, so you're going to actually see that it recognizes these pairs as latitude and longitude. And where is this? Let's zoom out. So this single warehouse location is right here near Springfield, Missouri. So that's the optimized single warehouse location. So now how about two warehouses? Now we come back to the spreadsheet. So in the two warehouse spreadsheet, we have the same information, the cities, the latitude, the longitude of each city, and the shipment volume to these cities. Now we're going to calculate the distances to the two warehouses. So now we have two distances. Distance 1 to warehouse 1 and distance 2 to warehouse 2. Let's calculate these distances. This is equal to 69 times sqrt, the square root, parenthesis, again parenthesis, of the latitude of this city, New York, minus the latitude of warehouse 1, lock this using F4, close the parenthesis, and square, plus the longitude difference, parenthesis, the longitude of New York City, minus the longitude of the first warehouse, F4 to lock it, close the parenthesis, and square, and then close the parenthesis of the square root, and then enter. So that's the distance to warehouse 1. Make it easier to read. All right. So distance 2 is equal to, similarly, 69 times sqrt, parenthesis, parenthesis, this latitude minus warehouse 2's latitude, F4 to lock it, close the parenthesis, take a square, and then plus parenthesis, now it's the longitude difference, this longitude minus warehouse 2's longitude, F4, and close the parenthesis and take a square, and then close the square root parenthesis. So enter. And let's format this. Okay, so now we have the two distances. They are the same because we didn't put anything about the warehouse location. Actually, I can easily put in some numbers here. Let's say one is 40, the other is 35. This is minus 75, this is a minus 80. So these are just some random locations. Now we see the distance difference. All right, select these two and copy them down. Drag this all the way. So now we have distances. So we have the distances of these cities to these two warehouses, but we need to pick the warehouse with the smaller distance. So next we're going to calculate the mean distance. It's equal to mean parenthesis of these two distance numbers, F2 to G2, and close the parenthesis and enter. So that selects the minimum distance of these two. Okay. Copy this. So after we calculate the mean distance, we need to know for each city which house is it assigned to. So we're going to calculate the assigned warehouse. And that is equal to, we're going to use the formula that we have used before. It's called a match. So what do we look for? The mean distance, comma, where do we look for it? The two distances, and comma, and we want to do an exact match. The third parameter is 0, and then close the parenthesis and enter. So what match does, let me remind you, is that it's going to search for this number. If it finds the number in the first of the sequence, then it's going to be 1. If it finds the number in the matches the second in the sequence, it's going to be assigned to 2. So if we copy this down, we'll see that 3 of them assigned to 1, all the others to 2 for these random locations I have put in. So now we're going to be able to calculate the shipments times the distance that we have done earlier. So it will be equal to the shipments times the distance. Here we're going to do the mean distance because that's what we are picking. So mean distance. Now we have the shipments times the distance. Copy this down. And similarly, we're going to calculate the total. It's equal to the sum of all these shipments times distance. close the parentheses, enter. And also we want to calculate the mean distance. It will be equal to this total number divided by the sum of the shipments. And then enter. So now we are going to minimize this total by using solver. And in this case, remind you that since we have done a mean calculation here, our total is not smooth anymore. So we are going to need to use the evolutionary solver to do this instead of the GRG nonlinear. So go to data and solver. So we're going to select objective as total, and the non-max, we're going to do the mean. We're going to minimize this total here by changing the variable cells in this area. So the two warehouse latitudes and longitudes. And again, we're going to add constraints. Add. So the latitudes, we have talked about this, for the US would be below 50. So it's less than or equal to 50. Click OK. And then we can add, they are both positive, so they should be larger than or equal to 0. And if we click add, it's going to keep adding. So add, and it's already there. We can keep going with this. The longitude, again, as you remember, it should be less than 0. And add, and then select the longitude again. Now we're going to add the final one. They should be larger than or equal to negative 150, and click OK. So these are constraints we have added. We don't need this anymore because we have constrained all the variables that we need. And here, the solver we need, again, is evolutionary. And click Options. So within evolutionary, usually I set the maximum timeout without improvement to at least 300 so that it doesn't come out too quickly. 300 seconds, it's basically 5 minutes. Okay, there's no reason to change anything. And click OK. And then now we click on Solve. Click OK. And now we have these two new warehouse locations. And where are they? Let's take a look. So we select warehouse 1, Control C, and then we'll go to Google Map, Control V, put in these locations, and enter. So this location is near Lexington, Kentucky. This is warehouse 1's location. If you are old enough, you might actually remember we received a lot of packages from Amazon in early times from Lexington, Kentucky, and that is actually where the optimal location of the warehouse is. And warehouse 2, let me copy warehouse 2 location here, Control C, and go back to Google Maps, Control V, paste them, and enter. And warehouse 2's location is in California, a little bit north of Los Angeles. If you're using a Windows-based Excel, here's something more you can do. If you are using a Mac-based Excel, there's no luck here. So go to Insert, and instead of doing this map, which limits you to locations and fillers, you can use the 3D map function in Excel, but this is only available on Windows-based Excel. So to do that, first, we want to name this as a table. So select city, category, latitude and longitude, and insert table. And my table has headers. Click OK. Now we have created the table. Let me change this color so that it's easier to read. Okay, so now we have the table here, and then go to Insert, 3D Map. And Excel is going to create the map here. We want to use the category so that it has categorized cities and warehouses using different colors. Let me flat the map. So now we actually can see that, let me use this. So now we actually can see that the blue ones are the city locations that we have used to make warehouse location decision, and the yellow ones are the warehouse locations in the two warehouse case. Let me close this, and that concludes this video.